All right, so we're going to look at a few problems from section 1.2 just to see what preimages and images preserve when you're applying them to various unions, intersections, differences, etc. So problem number 2D, which we haven't looked at yet, and actually, so for all of these problems, we're assuming f from a to b, so f is a function from a to b. We're assuming that a0 and a1 are subsets of a, and we're assuming that b0 and b1 are subsets of b for all of these. Okay, so number 2D tells us that preimages of the difference of sets b0 minus b1 is equal to the difference of the preimages. And here we don't have to put any sort of special conditions on our function. So this is just any function f whatsoever. Okay, so how we go about doing this? Well, because it's an equality, we need to prove both directions. So let's take a look at this direction first, and let's let x be an element in the preimage of b0 minus b1. Okay, so by definition of preimages, that tells us that the image of x has to be in b0 minus b1. And so that, recall what that difference of sets means. So that means that f of x is in b0 and f of x is not an element of b1. Well, from there we can say that x is in the preimage of b0 and x is not in the preimage of b1. Well, if that's the case, then we can say that x is in the difference of those preimages. All right, so that proves that direction. And then to prove this direction, let's let maybe little a be an element of the preimage of b0 minus the preimage of b1. If that's the case, then we know that a is in the preimage of b0 and a is not in the preimage of b1. Let's squeeze that in there. Boop. Maybe. I can shrink that down a little bit. There we go. All right. So if that's the case, then we know that the image of A is in B0 and the image of A, image of A is not in B1. So we know then that the image of A, I don't know why I keep writing A0, the image of A is in B0 minus B1, and if that's the case, then we know that A is in the preimage of B0 minus B1, and so that proves that direction. And you guys can ask any questions about those in our Facebook. All right, so I want to quickly go through E and F that we did in class. So E tells us that F preserves inclusions. So that is that if A0 is a subset of A1, then the image of A0 is a subset of the image of A1. And this is pretty straightforward. So we're going to suppose the hypothesis that A0 is a subset of A1, and then we're trying to prove the inclusion. So we're going to pick some element in F of A0, and we want to show that Y is an element of F of A1, and this is pretty straightforward. So if Y is in F of A0, then we know that there's some element in A0 such that Y is equal to F of A, right? That's what it means to be in the image set. But since A0 is a subset of A1, we know that A is in A1. And so that tells us that F of A, or the image of A, is in the image of A1. But F of A is equal to Y, so that tells us that Y is in F of A1. So that's all we had to do for E. That one's pretty straightforward. For F, we're trying to show that F preserves unions. So that is if I take the image of a union, and then that's equal to the union of the images. All right, so just like D, we have to show both directions of inclusion here since it's an equality between sets. So let's take a look at this direction first. So we're going to let Y be in the left-hand set, so the image of A0 union A1. And so I'm going to use that image definition to tell me that there's some element in that union such that, sometimes I use ST, sometimes I write out such that, but such that Y is equal to F of A, right? So since A is in that union, that tells us that either A is in A0 or A is in A1, which tells us that the image of A is in the image of A0, or the image of A is in the image of A1. So since the image of A0 is a subset of the image of A0 union the image of A1, and similarly the image of A1 is also a subset of the union of that set with the image of A0. We get, in both cases, because every time it's or, it's cases, right? So in both cases, we have that F of A is an element of that union. And since y is equal to f of a, we've proved this direction. Yeah. So then the other direction, we're going to pick an element. I'm going to call it B, and we're going to let that live in f of a naught union f of a1, and we're trying to show it lives in the other set. So here we want to use the definition of union, and that tells us that B is in f of a naught, or B is an element of f of a1. And this is where we really have to break this thing down into cases. So if B is an element of f of a naught, what that tells us is that there exists, I'm going to call it little a naught in a naught, such that B is equal to f of little a naught. And since a naught, big A naught, is a subset of a naught union a1, we know that little a naught is an element of big A naught union a1. And so therefore the image of little a naught is in the image of that union. But f of little a naught was B, so B also lives in the image of that union. And we can just say similarly, if B is in f of a1, that's also going to imply that B is in the image of that union for basically it's the same argument as before. All right, so that's problems from number 2.